Today's lesson is about angle pairs. Pairs of angles. Quick overview. There's something called adjacent angles. Adjacent just means right next to each other. So for example, these two angles, right, the angle right here and the angle right here are adjacent angles. There are complementary angles. Now complementary angles add up to 90 degrees. And you know that a right angle is a 90-degree angle. So two complementary angles, if they were adjacent, if they were sharing a side, would form a 90-degree angle. But they don't have to be touching to be complementary. They just have to add up to 90 degrees. So you know, if this was 50 degrees and this was 40 degrees, angle 3 and 4 would be complementary. Then we have supplementary angles. Supplementary angles add up to 180 degrees. A straight line forms a 180 degree angle. So two angles that are supplementary, if they're adjacent like these are, will always form a straight line. But they don't have to be adjacent, they don't have to be touching in order to be supplementary. So if angle 8 here was 100 degrees and angle 7 was 80 degrees, well, that adds up to 180. So these two angles would be supplementary. Let's see, complementary, linear pair. A linear pair, well, we just were looking at a linear pair. When you have a pair of adjacent angles that make a straight line, that's a linear pair. So angle 5 and 6 are a linear pair. So you can probably see the connection between those two concepts. A linear pair will always be supplementary. So name a pair of angles here that are a linear pair. Well, let's see. Angle 1 and angle 2 are a linear pair because they make a straight line. But also, for example, angle 1 and angle 4, those are a linear pair because they make a straight line if you look at it this way. Alright? And there are more examples in there too. But if the angles make a straight line, they are a linear pair. Then we have vertical angles. Vertical angles, when you have intersecting lines like this, then angles like 1 and 3 are vertical angles when they're across from each other. So angle 1 and angle 3 are vertical angles, and they will always be equal. Alright, so if this is 25 degrees, then this will be also 25 degrees. But at the same time, there's another pair of vertical angles because angle 2 and angle 4 are also vertical angles. Okay, so if this was 100 degrees, this would also be 100 degrees because vertical angles are equal. Okay, that's it. So we are supposed to identify each pair of angles as adjacent, vertical, complementary, supplementary, or a linear pair. We're going to name as many things as apply. So in problem number 1, we're talking about angles 1 and 2. Angle 1 and 2 are right next to each other. They share a common side, so they are adjacent angles. They are not vertical angles. They are not complementary. They don't add up to 180 degrees, so they're not supplementary, and they're not a linear pair. You know, because angle 1 and 2 by themselves do not make a straight line. So adjacent is the only thing we can say about that. Okay, what about number 2? Let me copy this text box over real quick. Angle 3 and 4 here are vertical angles. Alright, vertical angles are those angles that are like across from each other. So we don't know anything else other than that. They're definitely not adjacent. We don't know if they're complementary. We don't know that they're definitely not supplementary. They're not a linear pair. So vertical is all we got. Number 3 is going to be the same thing as number 1. Alright, number 3, these two angles, angle 5 and 6, are adjacent. Guess I don't need all this space. Those are adjacent, but that's all we know. Alright, they're right next to each other. We don't know any of this other stuff. So, we got nothing. Okay, what about number 4? Okay, for number 4, we have a little bit more information. What do you think? Are they adjacent? Yeah, they're adjacent because they're right next to each other. Are they anything else? Well, they are a linear pair. Because of the way together they're, the side that they don't share forms a straight line. And a linear pair is always going to be supplementary. Alright, they add up to 180 degrees when it makes a straight line. So I think that's all we have. Adjacent, supplementary, linear pair. Okay, these 3 will always go together. Alright, if you have a linear pair, it's always going to be adjacent and supplementary. Anyway, 9 and 10. Again, we know that they are adjacent because angle 9 and angle 10 are right next to each other. But we don't know anything else for sure. It doesn't quite look like they add up to 90 degrees. It looks a little acute, even the pair of them together. But anyway, we don't know any degrees or anything, so we can't assume anyway. So that's all we got is adjacent. And then 11 and 12. Well, 11 and 12 are just like number 4 again, so I'm just going to copy this guy. It's this triple word score. They are adjacent, they are a linear pair, they are supplementary. Okay, not much to say there. What about number 7? Well, number 7 is just like number 2. These are called vertical angles. Alright, when they're right across from each other like that. Now we have some numbers to work with. Now at a glance, it's looking like maybe this is a 90-degree angle. It's looking roughly like a right angle. But we don't have to guess. Let's add these up and see if they add up to 90 degrees. Well, 50 plus 30 is 80, and 5 plus 5 is 10. So that's a total of 90. So they add up to 90 degrees, so what do you call that? That is called complementary. So these two angles are in fact complementary. Okay, what about these two? They're not, oh, you know what, wait, I almost left out one. They're complementary, but also they're right next to each other. So they're also adjacent. So let me not leave that off the list. They're complementary and adjacent. Okay. Number 9, these are not adjacent, alright, they're not touching. But they are supplementary because they add up to 180 degrees. 40 plus 40 is 80. So, I need a text box. Alright, and that's all I can say about these. They are supplementary. Okay. Alright, that's it for that type of question. Use the figure at right to answer each question. Okay, bring it. Name 2 acute vertical angles. Remember, acute means less than 90 degrees. Okay? And I can use this square to help me judge if I need to. Because this square, every corner of this square is a 90-degree angle. So if it's going to be acute, it has to be smaller than this corner. And if it's going to be obtuse, it needs to be larger than 90 degrees, larger than the corner. Anyway, name two acute vertical angles. Well, let's start with the vertical angle part. If you look at two intersecting lines, they are going to form vertical. Alright, these two lines right here are intersecting lines. So they are going to form the vertical angles that I need for this problem. Okay, so this angle and this angle, these are vertical angles. So, and they are acute. And if you don't believe me, you could come over here and try to put this square in here, but you see it doesn't fit because this angle is too wide. So these are acute angles. Alright, save that for later. So we just have to name them. One of them we could call angle FGE. The vertex always needs to be the middle letter. So let's see, I'm going to make this little. So I could say angle FGE. Or I could have said EGF, but angle G has to be in the middle. I can't just say angle G because look how many angles share that vertex. So that would be ambiguous. And the other one is this angle over here, angle CGD. Alright, those are my vertical angles. Now, name two obtuse vertical angles. Okay, well, vertical angles always come in two pairs. So you kind of need to ignore these two black lines because they're going to distract you. I'm going to help you ignore those lines by sort of whiting them out a little bit. So just temporarily ignore this line right here. Okay, sorry if you have OCD and you don't like the fact that I'm leaving part of the line showing. But it's hard to see what you're doing when you're dealing with white. If I scribble a little bit more. Alright, anyway, you get it. Ignore those lines. So if you ignore those lines I just erased, that's going to make it easier for you to see what's going on around here. Am I right? Go back to a manageable size. So these angles over here are also vertical angles. Okay, so this angle and this angle. These two angles that I just marked in purple are also vertical angles. So angle FGC is obtuse. Okay, clearly that's bigger than 90 degrees. Alright, FGC is one of them. And the one down here is angle EGD. Okay, that's a horrible G, but I'm going to leave it. Name a pair of adjacent angles. Well, I'm going to have to unerase some of the stuff that I just erased. Alright, a pair of adjacent angles. Alright, there are several examples that you could choose. I'm just going to list this one example. I'm not going to list them all. This pink angle and this green angle are an example of adjacent angles because they are touching each other. They share a side. So using this example, in fact, if you're watching this video and you actually have this as a homework assignment, you need to pick a different pair. Don't use my pair. Alright, that's cheating. I won't accept it. I will reject it. And I'll know you copied the answer key. In fact, I'm going to use this as a test. Anybody that picks this pair, I'm going to assume that you copied. Okay, because what are the odds? We just finished a unit on probability. I should have you calculate what the odds are. Anyway, angle FGA. Okay, you pick something different. And angle AGB. Angle AGB. These are adjacent angles. The important thing is that they share a side. Okay, in this case, side GA and AG, right? They share, they share side AG. Anyway, moving on. Name a linear pair. All right, again, there are many examples of linear pairs. So again, this is going to be a great assignment for me to see who the copiers are. Because if you have my answer for number 12 and my answer for number 13, all right, the chances of just accidentally picking the exact two angles that I picked both times are astronomical. So I'm going to be looking to see who puts these, because that's someone who obviously didn't watch the video. Because if you watch the video, you know not to do that. But if you're just pulling up the answer key and copying down the answers, I'm going to get you. So that sounded sinister. I'm going to get you. Nothing's going to really happen to you except that I will know that you're a cheaty McCheaterson. Anyway, angle FGA. Okay, FGA and angle AGD are a linear pair. Because of the way that if I look at this side over her, see how this makes a straight line? That's why it's a linear pair. Name a pair of complementary angles. Complementary angles have to add up to 90 degrees. So they're not giving us any angle measures. So I'm not 100% sure how we're supposed to know what adds up to 90 degrees. I guess we're supposed to assume. I'm not feeling this question. Now, I don't like to assume, and you're not supposed to assume anything, but I don't see any other way. It seems like this line right here is perpendicular to line AG. I'm going to cheat a little bit. Wait, is it going to let me? If I do my tool, if I rotate this 90 degrees, kabam. I should have copied it first. Hold on. But notice how it does land on AG, sort of proving that it is in fact perpendicular. Okay, very clever. Proud of myself. So I sort of proved that these are in fact perpendicular by using the tool and rotating it 90 degrees. All right. Didn't it say? Yeah, see, it says 90 degrees right there. So that sort of guarantees me that it will be not exactly 90 degrees. Anyway, so I have two pairs of complementary angles that I could choose from. Let me make this shorter looking, because that's not really, whoops, it's not really part of it. Darling, why is that moving when I do that? Okay, I give up. That is the weirdest thing I've ever seen. Anyway, just ignore this side of the line, because that's not supposed to be doing that. Okay, there, I fixed it. OCD. So if I look at this side of the perpendicular lines, you see the pink angle and the green angle nestled inside of this 90-degree angle over here. That means that these two will be complementary. So the pink and the green, that's one example. So that's angle EGF, angle EGF, and angle FGA. Okay, but there's another pair of angles over here. I could have said angle AGB and angle BGC. All right, again, don't use my pair. All right, because I'm going to be looking for who's copying. So now I've got 3 different answers that had multiple choices, and if you write down my exact 3, I'll know you're a cheater. You'll be mocked for life, my friend. Anyway, I'm getting carried away. Name an angle supplementary to angle FGE. Okay, let me mark angle FGE. Alright, so here's FGE is this pink angle right here. We want an angle that's supplementary to it, meaning it has to add up to 180 degrees. Now, I left this blue line showing because a straight line is going to make 180 degrees if you look at it as an angle. So I need to pick an angle pick an angle that will complete this straight line. So I'm going to go ahead and draw the other angle in green, but you can see that it'll be the angle that goes from here to the blue line. Okay, so this green angle is supplementary to the pink angle because you can see how they form a linear pair, okay, because of the blue line. So the angle that is supplementary is angle FGC. FGC. Alright, see how I'm going blue, purple, blue, purple? No, that's not an accident. I knew you liked that. You're welcome. Alright, so now we're switching figures, but it's the same type of thing. Alright, name two acute vertical angles. Alright, vertical angles, those are when the lines cross, and let me trace some things out. Okay, so I find myself looking at, at these two lines for my vertical angles. So these are vertical angles, for example, and these are also vertical angles. But we want the ones that are acute right now. And acute means less than 90 degrees. So it looks like these are the angles that are less than 90 degrees. So that's going to be angles EKH and angle FKG. Alright, now name two obtuse vertical angles. Well, that'll be the other pair. Okay, these will be the obtuse ones out here. Okay, bigger than 90 degrees. So that's angle EKF and angle HKG. Okay, name a linear pair. So I am looking for two angles that form a straight line. So I'm going to pick this straight line. Alright, you could have picked the other one. So there are multiple correct answers. And again, I'll be using this to judge who's copying me. So if you want to be slick about it, pick something else other than whatever I'm about to say. Alright, so for example, these two angles, the pink and the green, form a linear pair because you can see how the side that they don't share forms a straight line. So you find a different linear pair in the picture and pick that. Don't copy. So, but this linear pair is angle HKE. So HKE. Alright, and this linear pair is angle EKF. Okay, EKF. Alright, for number 4, we want two acute adjacent angles. Alright, well there's a bunch of them. So we need angles that are less than 90 degrees and that are right next to each other. So I'm just going to pick a couple. Okay, so these angles both look acute and they are definitely adjacent. So this would be one example of acute adjacent angles. There are others. I could have picked these two over here. So, or even these two right here. So you have lots of choices. Actually, is this 90 degrees? Let me check this. This might not be acute. I'm using my square to test it out. This is looking like a 90-degree angle now that I look at it. So that pink one was a bad choice. I could have picked this one over here, but actually it's going to have to be this one over here. So it's all about the green one and this one over here. This pink one, that's a no-go. That's 90 degrees. That's not acute. That's a right angle. Okay, so let me try that again, people. One more time. Okay, that's better. So these two angles are acute and adjacent. They're less than 90 degrees and they're touching. So let's name them. JKG and angle FKG. Okay. Excellent. All right, name an angle complementary to FKG. Well, I think I just did that. Because like I was showing on this side, it looks like these are complementary angles. All right, this seems to be a right angle in here. So that means these two angles, the pink and the green, are complementary angles. So an angle complementary to FKG is the green angle JKG. So I can really just use my answer from before. JKG would be complementary. Now, name an angle supplementary. So still dealing with the pink angle, okay, FKG, but now I want a supplementary angle. Get rid of that. So I'm going to get this angle right here. So the pink angle and the green angle, these are supplementary. Or I could have done the pink angle and this angle up here. I guess that would have been even more obvious because that's also a linear pair. So I'm doing this one. So why don't you do this one? All right, to show that you're not copying right off the answer key. Okay, but I'm going to use this one down here. HKG would be supplementary. Okay, more than one right answer. So that's it for the naming business. Alright, so now it's time to solve some things. Okay, so we're supposed to find the measure of each numbered angle. Well, the measure of angle 2 is 57. I'll just put that here for a second. So if that's 57, then these two have to add up to 180. So all I need to do is go 180 minus 57, and that'll give me the measure of angle 1. Okay, so the measure of angle 1 is 123. So that'll be the answer to number 7. Well, these are vertical angles. And vertical angles are equal. So if angle 1 is 38, then that means the measure of angle 2 is also 38. Number 9. Angle 5 and 6 are nestled inside of a 90-degree angle. Alright, you can tell because this is 90 degrees over here. So these have to add up to 90 degrees. So all I need to do is to do 90 minus 22. and that is 68. So that'll be the measure of angle 6. Again, vertical angles are equal. So if angle 1 is 65, then that means the measure of angle 2 is also 65. See this linear pair? They have to add up to 180 degrees. So all I need to do is to subtract 180 minus 67. Alright, that is 113, so that'll be the measure of angle 1. Angles 3 and 4 are sitting inside of a 90-degree angle, so they have to add up to 90 degrees. So all I really have to do is go 90 minus this 38. And that is 52. So that's the measure of angle 4. Alright, number 13 takes slightly more work. We know that these two angles have to add up to 180 degrees. And here we have these expressions. So they have to add up to 180 degrees. So that means that 4x plus 11, okay, that's one angle, plus 3x plus 1, that's the other angle. Together, they have to add up to 180 degrees. So it's just a matter of solving this equation and plugging back in. So these parentheses are not really doing anything but grouping. So for now I'm going to erase those. So I'm going to combine my like terms. 4x plus 3x, that makes 7x. 11 plus 1 makes 12. And so that equals 180. Let's subtract 12 from both sides. So that's going to leave me with 7x is equal to 168. And then we will divide both sides by 7. So x is equal to 24. Now, that's not the final answer. We need to find the measure of angle 13 and angle 14. So we need to plug this back in. Okay, so the measure of angle 13 is 4x plus 11. So that's 4 times 24 plus 11. So the measure of angle 13 is, you could use your calculator to help you out, that's 107. That's not the right assignment. Okay, so that was the measure of angle 13. It's 107. Okay, we could do the same thing to find the measure of angle 14. That's 3x plus 1, so that's 3 times 24 plus 1. That's 73. Alright, these are vertical angles, and vertical angles are equal. So I'm just going to set these equal to each other. So that means that x squared minus x plus 12 is equal to 4x plus 6. We just have to solve this. Let's subtract 4x from both sides. So minus 4x minus 4x. And while we're at it, let's subtract 6. I'm trying to get 0 over here. So I'm going to subtract 6 from both sides as well. So I'm just going to bring down the x squared. Now negative x and negative 4x, that's negative 5x. Positive 12 minus 6, that's positive 6, equals 0. So I just need to solve this. this is quadratic. I see the x squared. This is probably factorable. X squared is x times x. 6. I'm either going to do 2 times 3 or 6 times 1. Alright, I'm thinking it's going to be the 6 times 1. Now remember, inner plus outer has to equal middle. Inner, I've got 6x. Outer, I've got 1x. I'm trying to get negative 5. I can get that if I have negative 6 and positive 1. So there's my negative 6 and there's my positive 1. Whoops, that's not going to work out though, because negative 6 times positive 1 would be negative 6. Okay, and I need it to be positive. So using the 6 and 1 was a bad choice. So instead, I'm going to go with the 2 times 3. Just make them both negative. So I've got 2x and 3x. If I make them both negative, that'll give me negative 5x. Negative, negative. But also, a negative times a negative is a positive, so that works out as well. So that's how you factor it. But you have to keep going and set these equal to 0. So x minus 2 equals 0. X minus 3 equals 0. Adding 2 to both sides gives me x equals 2. Adding 3 to both sides gives me x equals 3. Alright, so this is interesting because I have 2 possible answers. Let's see what I get if I plug in the 2. Alright, that would make this 4 times 2 plus 6. Alright, so that would make it, that's 8 plus 6, so that's 14. Okay, so that's 14. So that's one possible answer. Alright, the measure of angle 2 is equal to the measure of angle 3, which equals 14. Now, what happens if I plug in 3 instead? Well, if I plug in 3, 4 times 3 is 12, plus 6 is 18. Alright? So maybe it's 18. Okay, I guess the drawing is not to scale because both of these look considerably bigger than 14 or 18. But anyway, that's the answer. Well, there's 2 possible answers, either 14 or 18. Alright, number 15. These two have to add up to 180. They are supplementary. Alright, so that's a little bit tricky. So like we did before, x plus 10 plus 3x plus 18 has to add up to 180. Now, once again, these parentheses are not really doing anything except for grouping. X plus 3x is 4x. 10 plus 18 is 28. And that has to equal 180. Now, let's subtract 28 from both sides. That gives me 4x is equal to 152. Now we divide by 4 on both sides. I'm starting to lose my voice now, so I've got to get to the end of this lesson quick before my voice dies. Let's see, divided by 4, you say, that's 38. Alright, but we're supposed to find the measure of angle 1 and the measure of angle 2. So, if I plug in this 38 right here, that gives me 38 plus 10, so that's 48. Okay, so that's one answer, is that the measure of angle 1 is equal to 48. Now, if I plug in my 38 right here, right, that's 3 times 38 plus 18. That's 132. Alright, so those are the answers to number 15. Alright, vertical angles are equal, so we have to set these equal to each other. So that's going to mean 7x minus 24 is equal to 5x plus 14. When you have a variable on both sides of the equation, you need to subtract to get them together. So I'm going to subtract 5x from both sides to get these x's together. Now these x's cancel each other out. But 7x minus 5x is 2x. So now I have 2x minus 24 is equal to 14. Now let's add 24 to both sides to get rid of the 24. So that'll give me 2x is equal to 38. Alright, now I need to divide both sides by 2. So x is 19. But that's not the answer. I need to know the measure of angle 6 and the measure of angle 7. So imagine that I took 19 and I plugged it in right here. So that would be 5 times 19 plus 14. That's 109. Then again, vertical angles are equal. So that means the measure of angle 6 equals the measure of angle 7, which equals that 109 we just spoke of. Four and 5, they are shoved inside of this 90-degree angle. So they have to add up to 90. So in other words, 2x minus 5 plus 4x minus 13 has to add up to 90 degrees. I'm ignoring the parentheses. 2x plus 4x is 6x. Negative 5 and negative 13, well, that's negative 18. And that equals 90. Okay, adding 18 to both sides. So 6x will equal to 108. And then we'll just divide by 6 on both sides. So x is equal to 18. Whoa, that's a weird looking 18. But 18 is not the final answer. We need to know the measures of these angles. And they're not equal, so we have to do it separately. Let's see. If I plug in 18 right here, alright, so that's 4 times 18 minus 13. That's 59. Okay, so that tells me that the measure of angle 5 is 59. So far, so good. Now, what if I plugged in my 18 right here? 2 times 18 is 36. 36 minus 5 is 31. So that's the measure of angle 4. Okay, we're down to the last problem. Just thank goodness, because this video is getting long. It's kind of a long homework assignment. I hope it's only taking a long time because I'm taking all this time explaining everything in detail and drawing all these pictures. I'm hoping it's not taking you 44 minutes like it's taking me. Anyways, 7 and 8 are complementary. Yes, we can see that. Well, I guess we're not supposed to assume. Anyway, 5 is congruent to 8. Interesting. So let me mark that. So angle 5 and 8 are congruent. Angle 6 is 29 degrees. So let me put that. So this is 29. Okay, so I guess I'm supposed to find all these other angles. Well, if this is 29, so complementary means that these add up to 90. So the first thing I'm going to do is I'm going to go 90 minus 29 and figure out what angle 5 is. Okay, so what's that? 61. Alright, so the measure of angle 5 is 61. And angle 5 and angle 8, in fact, maybe I can just put these answers right here. So the measure angle 5 was 61. So obviously the measure of angle 8 is also 61, alright, because they are congruent. Yeah, so I already said angle 8 is 61. Now, 7 and 8 are complementary. Okay, 7 and 8 are complementary. So that means they have to add up to 90 degrees. So I can just, I could subtract 61 from 90, but I already know that's going to be 29. So in other words, this is 61, this is 61. This is 29, this will be 29. Alright, that's the only way that it can work. So this will be the 29. Alright, and that's it. We found all of the missing angles. So that was a very long lesson. I hope it was helpful. I'm going to bed. I'll see you on the next video.